Hey everybody, in this video we're going to be practicing finding absolute extrema on intervals. If you want to follow along, the links to the companion worksheet are in the description below, so let's get started. So the idea of finding absolute extrema is that if we look at an extrema, if we look at an interval, the function should have one high point and should have one low point. So the first thing you do when you want to find absolute extrema is, what are the endpoints? Okay, so we've got -4 and we've got 0. So we want to find out what are the values of those endpoints. So we want to plug in 0 and we want to plug in -4. Now 0 is pretty easy because that's going to zero out anything with an x. So that means we have 3. If we plug in -4 into these, let's see, we get -64. If we plug in -4 here, that's going to be plus 16 times 6 minus, and then we'll subtract 36, and then we'll add 3. So that gives us a value of -1. Now, these could be the high and low values of our interval, but we don't know. But this is our starting point. From there, we then take the derivative. So f prime of x equals 3x squared plus 12x plus 9. And what we're looking for is are there any places on this interval where the function changes sign? So in a sense, we're finding critical values. We're finding where the derivative is undefined and where it's 0. Now looking at this, it's a quadratic. So the derivative is never going to be undefined, but it will equal 0. Or will it? So let's try and solve this. Plus 12x plus 9. Well, we can factor a 3 out. So we have 3, and then we have x squared plus 4x plus 3. All right. So now we can factor that further into x plus 1 and x plus 3. So the values we get are x equals -1 and x equals -3. So these are values where the slope is 0. Those are critical points. And so we have to ask, all right, what are those values? So now we find the coordinates of these 2 points. So if we plug in -1, this is going to be -1 plus 6, 6 minus 9 plus 3. So that's going to give us a value of -1. And then if we plug in -3, that's going to be -27 here, minus, or no, that should be plus 54, minus 27, plus 3. And so that gives us a value of 3. So for the absolute extrema, now different books will ask this in different ways. Sometimes it'll ask what is the highest value or the lowest value. Sometimes it'll ask what is the x-coordinate or of the absolute extrema. So I'm just going to ask where are the coordinates for the absolute minimum and the absolute maximum. So for the absolute maximum, our coordinates are x equals 0 and x equals -3. And so for our absolute minimum, we will get x equals -4 and x equals -1. And so this is how we find absolute extrema on an interval. So now let's look at number 2. Here we've got this function, and so we want to look at the endpoints and see, well, if we plug in 3 and if we plug in 6, what will our values be? So if we plug in 3, we should have 9 on the top over 9 minus 6, so that's 9 over 3, so we get a value of 3. If we plug in 6, that means we have 36 on top over 18 minus 6, so that's 36 over 12, so that looks like, yeah, that should also be a value of 3. Wonder what else might show up. So let's find the derivative. So our derivative, we're going to use quotient rule. So low d high, so 3x minus 6 times 2x minus high d low, x squared times 3, all over 3x minus 6 squared. We're definitely going to need to simplify this out, so we'll expand it. So 6x squared minus 12x minus 3x squared, all over quantity 3x minus 6 squared. And so that simplifies to 3x squared minus 12x over 3x minus 6 squared. Now we're asking for the critical points, which are when is the derivative 0 and when is the derivative undefined. Well, here the derivative is going to be undefined when the bottom equals 0. So if I set 3x minus 6 equal to 0, I'm going to get 3x equals 6, and so x equals 2. So that's when the function is undefined, but interestingly, that's not within our interval, so we're not even going to consider that. So all we do consider is what values will make it 0, will make the derivative 0. So we have 3x squared minus 12x equals 0. So we factor out a 3x, so we have x minus 4, and so we have x equals 0, and x equals 4. But again, 0 not within our interval that we stated. So the only thing we're concerned with is 4. So what is the coordinate at 4? So if we plug 4 in, we get 16 on the top, and on the bottom we have 12 minus 6. So that's going to be 16 over 6, or that would be 8/3. And so 8/3 is actually less than 3. So for our absolute maximum, that happens at x equals 3 and x equals 6. And for our absolute minimum, that happens on x equals 4. All right. For the next one, here we've got this function and the interval from 0 to 5. So if we plug in 0 for our endpoint, we have 8 over 4, which is 2, and then we plug in 5. So that is 8 over 5 squared is 25, plus 4 is 29. So we have 8 over 29. So now we find the derivative and see where is the derivative undefined and where is it 0. So f prime of x equals low d high. So low d high, now the derivative of 8 is going to be 0, so we don't need to write that, minus high, minus 8 d low times 2x, all over low, so x squared plus 4 squared. So we get negative 16x over x squared plus 4 squared. Now, when is this going to be undefined? Well, whenever this is equal to 0. But looking at it, the smallest that x squared can ever be is 0. Plus 4 means the smallest that this quantity can be is 4. And if we square that, then the smallest that this quantity will ever be is 16, which means the denominator has no chance of ever being 0. So the derivative can't be undefined. It just can't equal 0. So the only thing we have to concern ourselves with is the numerator. So when we solve x, when we get x by itself, we get x equal to 0. But as it turns out, we already identified that up here. And so, yes, it turns out that this has a slope of 0, but we've already identified it as an endpoint. So we can go ahead and say that our absolute maximum is at x equals 0. And our absolute minimum is at x equals 5. So finding the derivative in this case didn't introduce any new critical points. But since we don't know that, we have to find the derivative every time. So with number 4, here we've got x plus 2 to the 2/3, and we have negative 4 and negative 2. So negative 4, negative 2. Now negative 2 is pretty simple, because when we add 2, that's 0 to the 2/3 is still 0. When we take negative 4 plus 2, we get negative 2. And then when we raise that to the 2/3, we're going to get a decimal, so that's 1.587. So now we want to find the derivative. F prime of x equals, chain rule here, so we take the derivative of the outside, so the 2/3 comes down, times x plus 2 to the negative 1/3, times the derivative of the inside, which is 1. Now for continuity, the way we've been writing it with ratios and fractions, I'm going to write this as 2/3 times the cube root of x plus 2. All right. Now when is f prime 0? Well, it's when the top is 0, but the top is a constant, so we don't have to worry about that. And the bottom, f prime is going to be undefined when the denominator is 0. But we've already stated that's at negative 2, and we've already got that spot. So in this case, f prime doesn't give us anything new. So our absolute max and absolute minimums, like number 3, are going to occur at the endpoints. So absolute maximum, they occur at x equals, that's going to occur at x equals 4. And the absolute minimum, that's going to occur at x equals negative 2. All right. Now the next two are kind of cheats because they're actually open intervals. And so when we talk about endpoints, there's no point in talking about any endpoints here because we don't include either 0 or infinity here. So all we can do here is find out what critical points are there. So f prime of x equals 4x cubed minus 4x. Now thankfully, there's no radicals and there are no denominators, so we don't have to worry about f prime ever being undefined. We just need to find when f prime is 0. So we've got 4x cubed minus 4x, and that's equal to 0. So what we can do is we can factor out a 4x, and we're left with x squared minus 1, and then that can further factor into x plus 1 and x minus 1. And so the three values we get that are equal to 0 is 0 here, negative 1, and 1. But again, looking at the interval, negative 1 is not between 0 and infinity. 0 is not on the interval because there's no bracket here. If there were a bracket here, that would say that we were including 0. So 1 is the only value that we're including here on this interval. And so if we plug in 1 in for x, that'll give us our y value. So we have 1. So that's 1 minus 2 minus 3. So that's going to be negative 3. So that's our only extreme value. But the question is, well, wait a minute. Is that a minimum or is that a maximum? Hard to tell. So an easy way to tell is just pick another point. Let's try 2. It's not an extrema, but either it'll be above that or it'll be below it. So if we plug 2 in, 2 to the 4th is 16. And then minus 2x squared, so that's minus 8, minus 3. So that gives us a value of 5. So that means that all points should be above this point, which means this is an absolute minimum at x equals 1. And as far as an absolute maximum is concerned, there is none, because the function is going to keep growing forever onto infinity, and so it's impossible for it to have a maximum on this interval. Now for the last one, we are including 0 here. So that means we include 0. So if we plug in 0, we would get a value of 6. And so now we find the derivative to see any points where f prime is 0 or undefined. So 3x squared minus 6x. Again, like number 5, there's no radicals and no fractions. So f prime will never be undefined. So all we have to do is find out when is f prime equal to 0. So we factor out a 3x. So we have 3x and x minus 2. So what that gives us is it gives us x equals 0, which we already knew, and x equals 2, which we didn't know. So now, if we plugged in 2, what would be the coordinates for that? We plugged in 2 here, that would be 8. If we plugged in 2 here, that would be 12. And then we add 6. So we get a value of 2. Now the thing to be cautious of, when you have an open interval, the function could be growing forever. And so we need to check to see, are these actually the highest and lowest values on the interval? So what if I picked a value of 3? If I substituted 3 here, that would be 27 minus 27 plus 6. So I get a value of 3 comma 6. Now that's the same value as that. What if I picked a value of 4? If I picked 4, that's going to be 64 minus 48 plus 6. So I get a value of 22. So actually, the lowest value that this function ever gets is here at 2. But notice, as I plug in bigger numbers for x, the y values keep growing. So at first glance, some people would be tempted to say that this is a maximum, but actually it's not. We have an absolute minimum at x equals 2. But as far as an absolute maximum is concerned, this one is like number 5. As x grows to infinity, this function will also grow to infinity, so it never stops growing. So therefore, there's no highest value. There is no absolute maximum here. Thanks everyone for watching. If you liked the video, please give it a thumbs up. For more videos like this, click the subscribe button. If you're a teacher and you found this helpful, please share it with your colleagues or your students. If you're a student and this helped you out, please share it with your classmates. If you have suggestions or problems that you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.